In the name of Allah, the most gracious, the most merciful. Good morning, everyone. Now we are going to deal with our new program for mathematics department in Tabarak Private School with you, teacher Mohammed Albadry, with grade 11 mathematics teachers, and we are going to deal with the lesson of the sum to infinity. And before everything, we have to say big thanks for the chairman, Mr. Yunus Al-Rahbi. Now we are going to start with our new lesson, the sum to infinite.
And our lesson now is about factor and remainder theorems, and it's talking about how could we find the factors of any algebraic expressions and how could we know it's a factor or no. So the first theorem here for a factor theorem, it's about it's talking if ax minus b is a factor of function of x, that means the function of the zero of the factor ax minus b, by solving it will be b over a. So the function of b over a must be equal to 0 because here is a factor. But for the remainder theorem, if function of x is divided by ax minus b with the remainder c, that means function of b over a equals c. So the difference here between the factor theorem and the remainder theorem, the factor theorem, the function of the 0 equals 0, but for the remainder theorem, the factor of the 0 of the factor equals a number, not equals 0. So now here we have an example. Exercise 12C, page 199, number 2C. Prove that 2x minus 1 is a factor of 2x power 3 plus x squared minus 3 plus 1. So here to find it, we have to read the equation very well and carefully, because here we have a factor. A factor means we have to find the 0 of this factor. 2x minus 1 equal to 0. By solving, we will have 2x equals to 1, so divide 2, we will have x equals half. Now we have to find the function of half. So for the algebraic expressions, 2x power 3 plus x squared plus minus 3x plus 1, we have to replace each x by half. So when we substitute, we will have it 2 times 1 over 2 power 3 plus 1 over 2 power 2 minus 3 times 1 over 2 plus 1. When we substitute it, we will have the value equal to 0. So that means 2x minus 1 is a factor of the expression of 2x cubed plus x squared minus 3x plus 1. It will be the same. And now exercise 12C, page 199, number 3C. If x plus 2 is a factor of x power 5 plus 4x power 4 minus 6x squared plus ax plus 2, find the value of a. The same idea, but here we have a factor. So the 0 of x plus 2, when we make it equal to 0 and solving, we will have x equal minus 2. And here we have x plus 2 is a factor of the expansion, that means function of minus 2 must be equal to 0. So when we substitute it, we will have it negative 2 power 5 plus 4 times the negative 2 power 4 minus 6 times the negative 2 power 2 plus 8 times the negative 2 plus 2 equals to 0. When we simplify it, we will have it 10 minus 2a equals 0. So when we solve it, we will have 2a equals 10 divided 2 each term, so a equals 5. So when x plus 2 is a factor of x power 5 plus 4x power 4 minus 6x squared plus ax plus 2, the value of a equals 5. For the next exercise, here we have exercise 12D, page 200, number 1A. Find the remainder when x power 3 plus 3x squared minus 4x plus 2 is divided by x minus 1. It's easy, we just study it. We have to substitute the value of x now with 1, because the 0 here is 1. So it becomes x minus 1 equals 10, so the 0 is 1. So function of 1 equals 1 power 3 plus 3 times 1 squared minus 4 times 1 plus 2. It will be 1 plus 3 minus 4 plus 2, so function of 1 equals 2. So the remainder when x power 3 plus 3x squared minus 4x plus 2 is divided by x minus 1 is 2. And now for exercise 12D, page 200, number 2A. The remainder when x power 3 plus ax squared plus 3x minus 5 is divided by x minus 2 is negative 3. So the remainder is negative 3 when the expression x power 3 plus ax squared plus 3x minus 5 is divided by x minus 2. Find the value of a. So here we have to ask ourselves which theorem we are going to use, it the factor theorem or the remainder theorems. If we don't know it, we can find it in the question. The remainder, so that means we have to use the remainder theorem. So firstly we have to find the 0 of x minus 2. The 0 of x minus 2 is 2. Why? Because we are going to make x minus 2 equal to 0, so x equals 2. So now the function of 2 equals negative 3, because the remainder is negative 3 when we divide it by x minus 2. So here we have to substitute the value in the expression by 2. So becomes 2 power 3 plus 8 times 2 power 2 plus 3 times 2 minus 5 equals negative 3. By simplifying, we will have it 4a plus 9 equals negative 3. So 4a equals negative 12. So divide 4, a equals negative 3. So now the remainder, when the expression is divided by x minus 2 is 3, have a value of a is negative. And now we have a new exercise 12D, page 200, number 4, and it's application for the remainder theorem. So the remainder when 2x power 3 plus ax squared plus 4 is divided by x minus 2 is 5 more than when it divided by x minus 1. Find the value of a. Now to find the value of a, we have a relationship between the two remainders when it divided by x minus 2 and when it divided by x minus 1. So we have to find the zeros firstly. X minus 2 equal to 0 and x minus 1 equal to 0. We will have x equals 2 and x equals 1. But the relation here when it divided by x minus 2 is 5 more than. As is here means equal, and 5 more than means plus 5. So when it divided by x minus 2 means function of 2, is means equal, and 5 more than means plus 5, and function of 1. So now when we substitute to find it, it will be 2 times 2 power 3 plus 8 times 2 power 2 plus 4 equals 2 times 1 power 3 plus 8 times 1 power 2 plus 4 plus 5. Becomes 16 plus 4a plus 4 equals 2 plus a plus 9. So when we simplify, 20 plus 4a equals a plus 11. So now here when we are going to collect the like terms, we will have 3a equals minus 9. Divide 3, so a equals negative 3. So when the value of a equals negative 3, the remainder when we divide the expression by x minus 2 becomes 5 more than when we divide the expression by x minus 1. And now for the last exercise in factor and remainder theorem, exercise 12D, page 200, number 5. The remainder when ax power 4 plus 3x squared minus x plus 2 is divided by x plus 2 is 8 times the remainder when it divided by x minus 1. Find the value of a. To find it, how could we find it here? We have the same relations, but the previous exercise was 5 more than, but here we have 8 times. So if we want to solve it, we have to find the zeros of the factors here, x plus 2 and x minus 1 equal to 0, so becomes x equal negative 2 and x equals to 1. So now the relation, function of negative 2 is 8 times function of 1. So when we substitute it, it will be 8 times the negative 2 power 4 plus 3 times the negative 2 power 2 minus 2 plus 2 equals 8 times 1 power 4 plus 3 times 1 power 2 minus 1 plus 2. When we simplify it, we have 16a plus 16 equals 8a plus 32. So 16a minus 8a, when we collect the like terms, equals 32 minus 16, so 8a equals 16 divide a, so now a equals 2. And here the last exercise, and I hope you enjoy with our lesson of factor and remainder theorems. Thank you for your listening, and see you in the next lesson, and bye bye.
Thank you for listening for our explaining, and I hope you enjoy with us. And the homework, you can find it in the model and in your contact number in the WhatsApp and on the model. Thank you very much.